Assalamu-alaikum, this is Nafisa Javed and today we will learn about the quantum dots. Quantum dots basically are tiny specks of material. They're so small that some people say that they have no dimension, all in nano ranges. Right, they exist as points of material typically 1 by 10,000 the size of the human hair. History. In history, first of all, here is a scientist, Alex Ikimov. He was the first person who discovered the quantum dots. At the end of the 1970s, the Russian physicist Alex Ikimov synthesized the nanocrystals of copper chloride and then of cadmium selenide in a molten glass matrix. He then observed a fluorescence and a gradient of colors. Then there was an Alexander Ifros, the first to theorize the quantum dots. Alexander Ifros and other Russian physicists published in 1982 the first theory aiming at explaining the behavior of these very small crystals by the confinement of their electrons. Then Lewis Bros, the colloidal quantum dots discoverer. Inspired by the Alex and Ikimov, the American chemist Lewis Bros tried and successfully produced nanocrystal but in a liquid form to obtain a colloidal suspension. In this way, he obtained the first colloidal quantum dots of cadmium sulfide easier to handle and published his results in 1983. Now here are some properties of quantum dots. First of all, here is a color-changing phenomena, and you will be happy to see that quantum dots can emit any color of light from the same nanocrystal semiconductors simply according to their changes in its size. As I show a diagram, when the size of nanoparticle changes, the emission of radiations also changes. Basically, it's depend upon the bandwidth. As the band gap or the bandwidth increases, the size of nanoparticle decreases and the color of radiations becomes much intense. Okay. Then quantum dot structure. The quantum dots basically depends on three main components like the core, which is made up of cadmium silicate and cadmium sulfate. The shell, which is the inner one, the zinc sulfate, cadmium sulfate, and zinc silicate. And the outermost, which is amphiphilic surface. Now here is the toxicity of quantum dots, which is the third most important property of quantum dots as they are highly toxic in some situations. The reason is that when they enter in human body, or they can degrade degradations of quantum dots in acidic pH of endosomes, leading to surface coating absorption and cadmium plus 2 leakage. And as you know, cadmium is very toxic for humans especially. Reduction of reactive oxygen species ROS, which affect organelles and the plasma membrane integrity, and interaction of quantum dots with DNA leading to DNA damages. Here are some synthesis methods. There are basically two methods to synthesize the quantum dots, which are top to bottom approach and bottom to top approach. In top to bottom approach, there are further three methods: laser ablation method, X-ray lithography, and electron beam lithography. And I will discuss these all methods in detail in my separate videos. Bottom to top approach, including Solgen method, microemulsion method, and hot decomposition method. Now here are some application of quantum dots. Quantum dots basically are very important because they are used as sensing agents, as photodegradations, as a therapy, as imaging, and as diagnosis for different diseases. So what are the future perspective of quantum dots? They are high quality pictures. They can provide us high quality pictures. They can produce prototype products. They can also be used in defense applications or counter espionage, such as protection against friendly fire events by integrating quantum dots into dust that tracks enemies. And you will be happy to see that in this year, the scientists who get the Nobel Prize in the field of quantum dots as well. So you can understand this how widely spread this field right now. So this is all about the quantum dots. So thank you very much.